Hello, everybody. Here we are, 2.2 powers of 10 and the zero exponent. We're going to start with the definition, which is the zero exponent law. So if you could write this down, that would be great. And maybe I should try to type it since my writing is not always perfect. So it's the zero exponent law. And it states that a power with an integer base other than zero and an exponent of 0 is equal to 1. Okay, let's pump up the size on this. Can you see that? So power with an integer base other than 0 and an exponent of 0 is equal to 1. So hopefully you can see that, and I will show that this means that n to the 0, so any number with an exponent 0 is equal to 1, but that n, that number, cannot equal 0. Okay, so kind of hard to understand just saying it like that, so let's get into some examples and hopefully it'll make sense. So any positive power that has 0 as an exponent always equals 1. So said a little bit better there. So for example, 5 to the power of 0 equals 1. Oh, and let me see. Where do we have my blanks here? So any positive power that has 0 as an exponent, so make sure you're filling in the blanks, always equals 1. So for example, 5 to the power of 0 equals 1. 14 to the power of 0 equals 1. 2,394 to the power of 0 equals 1. Okay, you get the pattern. So if a power has a negative inside the brackets, then the answer is 1. If the power has a negative outside the brackets, or if there are no brackets, then the answer is -1. So I actually think that I changed this example slightly on your notes, so I put brackets right here. So for example, if we have the exponent outside the brackets, it's just going to be 1. So again, we have the exponent outside the brackets, it's just going to be 1. But here, when the exponent is actually the base of 4, we need to remember that that minus is going to follow it. And here again, if we have brackets just around the number, but not with the negative, that negative is going to follow along and be a -1. So the other thing that we're going to learn about is powers of 10. So when a power has a base of 10, the exponent tells us how many zeros there will be when the number is written in standard form. So make sure you're highlighting or writing it in as we go along. So if we look here, 10 to the power of 6 means that we have in standard form a 1 with 6 zeros. 1, 2, 3, 4, 5, 6. We have 10 to the power of 5. That means we have a 1 with 5 zeros. 10 to the power of 4, we got a 1 with 4 zeros, 3 zeros. 10 to the power of 2 is the one with 2 zeros. And 10 to the power of 1 just has 1 0, which means you can see that the powers are going down by 1 each time, and the zeros are going down by 1 each time. And that shows that if we have an exponent of 0, we're just going to end up with 1. So let's look at this backside of the sheet. This part can be a little tricky, so I'll go over it with you folks. So we need to know that any number can be written in terms of powers of 10. Okay, so for example, 129. First, let's break the number into individual place values. So this place right here is known as the hundreds. This is we call the tens spot, and this is we call the ones spot. So if we break this number down, we actually have 100, we have a 20, and we have a 9. We have a 1 in the 100 spot, we have a 2 in the 10 spot, and we have a 9 in the 1 spot. Then let's write each number as a product of 1, 10, 100, etc. So 100 could be written as 1 times 100, 20 could be written as 2 times 10, and 9 could be written as 9 times 1. Then we replace these, the 100, the 10, and the 1. We're going to replace them with a power of 10. So now this 100 became 10 to the power of 2, which we know to equal 100. So now we have 1 times 10 to the power of 2. This 10 became 10 to the power of 1. We still have our 2 there. And this 10, or this 1 here, became 10 to the power of 0, which we just learned is always equal to 1. So this is how 129 can be written as a power of 10. It's a lot longer. I mean, it's not as compact, but there you go. There you have it. So let's practice a few questions together. Maybe I'll do the first two, and then I'll let you folks try this one on your own, and then I can pause and come back to it. So let's look. We have a 6 in the hundred spot. So what this actually is this is 6 times 100. And we can show this as 6 times 100. What's a way to show 100 as a power of 10? That would be 10 with 2 zeros, so it's the power of 2. Next, let's look at this one. We have a 3 in the tens spot. We have a 5 in the ones spot. So we actually have 3 times 10 plus 5 times 1. So we could show that as 3 times 10 to the power of 1 plus 5 times 10 to the power of 0. I'll give you folks a second to do this one. It's got a lot of them, so we're going to end up with 5 different powers of 10. Let's see if you can get that. I'll pause it, and then I can come back. So hopefully we've paused now. And let's give it a go. So we actually have 3 times 10,000 plus, that's the 10,000 spot. We got a 2 times 1,000. We have a 1 times 100. We have a 5 times 10. And we have a 4 times 1. So these are all added together. Next, let's write them as powers of 10. So we got 3 times 10 to the power of, there's 1, 2, 3, 4, 5 zeros. So that's 10 to the power of 5. This is 2 times 10 to the power of, sorry, that's my bad. There's 4 zeros. This one is 10 to the power of 3. This one is a 1 times 10. We've got 2 zeros. This is a 5 times 10 with 1 zero. And this is a 4 times 10, 0 zeros. There you go. So we could just do the plus, or you could write it out in a better form if you want, which I guess could look like 3 times 10 to the power of 4 plus 2 times 10 to the power of 3 plus 1 times 10 to the power of 2 plus 5 times 10 to the power of 1 plus 4 times 10 to the power of 0. So I think this is good. Maybe this is slightly better. But there you have it. I will tell you what questions I would like you to do, and we can get started on that. Thanks so much. Bye.